Yes, this is chapter 3, scoping, and then visibility of variables, parameters and functions in one part of the program to another part of the same program. In other words, which part of your program can she or use it? Generally, this is called a scope, right? Next, in the scope, there are addresses, right? The addresses means references or points to an object in memory. When you assign a variable with colon equal to is nothing but assign to an instance or object, you are binding or mapping the variable to that instance, right? The multiple variables can be mapped to the same instance. Okay, so this is a variable scope. Next, here mapping. What is called mapping? Actually, this is a very important 2 mark and 1 mark. Okay, you are lucky. Luckily, sometime asking 3 mark also. The process of binding a variable name with an object is called mapping. Here, equal to sign is used in programming languages to map the variable and object. I think so it should be clear. Yes. Now, in this mapping, first we will see namespace, right? Here, the namespaces are containers of mapping names of variables to object. For example, dictionaries containing list of words and its meanings. The words are mapped with their meaning in dictionaries, where as names are mapped with object name equal to object, right? In programming language. Here in this session, next one is mapping. Suppose the value will be a equal to 5, right? Here b equal to, you have to assign to a. Mapping after change the value of a, it's nothing but interchange the value of a variable. First a equal to 5, b equal to 3. After the interchange the value of a variable, a equal to 3, b equal to 5. It is called a mapping process. You see, variable a, variable b, the allocated value is 5. Here mapping after changing the value of a colon equal to 5, b colon equal to 5, a colon equal to 3, right? Here a will goes to 3, b will goes to 5, right? In this process, here LEGB rule. Okay, so LEGB rule about we learn scope defines the order in which variables have to be mapped to the object in order to obtain the value. Okay, example, x equal to outer x variable, here display, here x equal to inner x variable, print x, here also display. The output will be outer x variable, inner x variable, right? Why? Because here also inner variables are there, here also outer variables are there. So what you learn from this coding, in this example, it gives different outputs because the same variable name x resides in different scope, right? One inside the function display and the other in the upper level. The value outer x variable is printed when x is referenced outside the function definition, whereas when display gets executed, right, inner x variable is printed, which is the x value inside the function definition. That's why the LEGB rule is used to decide the order in which the scopes are to be searched for scope resolution, right? Next, here scope hierarchy. Here the scopes hierarchy is nothing but simply outside what is the expansion of this LEGB. Many people are asking that questions, right? Here the LEGB is nothing but L for the local. Here E for the enclosed and then G for the global. The finally these will be do for a built-in, that's why that's called B. You see the local defined inside function or class, enclosed E defined inside enclosed functions, nested functions concept, global G defined at the uppermost level. Here built-in B reserved names in built-in functions modules, right? That's why simply we call LEGB. L for local, E for enclosed, G for global, B for built-in. Okay, that's why scope hierarchy simply we call LEGB rule, right? Now in that session, types of variables scope. There are 4 types of scopes in Python, right? And they are arranged in a hierarchy. Each scope is a context in which names are stored and in which they can be looked up. The 4 scopes from narrowest to broadest. Here narrowest to broadest. What they are said. First one is local and then enclosed and then global and then built-in, right? Here local is a names defined inside the current function. The second one is enclosed, names defined inside any and all enclosing functions. Third one is names defined at the top level of a module. Each module brings with it a new global scope. The finally we'll see about built-in, the names built-in to the Python language through the special built-in module, right? Next, in that session, module. What is a module? A module is a part of a program. Programs are composed of one or more independently developed modules. A single module can contain one or several statements closely related each other, right? Your modules work perfectly on individual level and can be integrated with other modules. A software program can be divided into modules to ease the job of programming and debugging as well, right? Next, we will see in this module, a program can be divided into small functional modules that work together to get the output, right? Here, the process of subdividing a computer program into separate subprogram is called modular programming. Modular programming enables programmers to divide up the work and debug pieces of the program independently. These examples of modules are procedures, subroutines, and functions. These 3 are important. The examples of modules are procedures, subroutine, and functions. Okay, and then we'll see what are the characteristics of modules. The first module is nothing but modules contain instructions, processing, logic, and data. Modules can be separately compiled and stored in a library, right? The third one is modules can be included in a program, and then module segments can be used by invoking a name and some parameters. The module segments can be used by other modules, right? Next, here what are the benefits of using modular programming? Here, the less code to be written, a single procedure can be developed for reuse, eliminating the need to retype the code many times. Programs can be designed more easily because a small team deals with only a small part of the entire code, right? And then modular programming allows many programmers to collaborate on the same application. Here, the next one we will see about benefits of using modular programming. The code is stored across multiple files. Here code is short, simple and easy to understand. Here errors can easily be identified as they are localized to subroutine or function. The same code can be used in many applications. Finally, the scoping of variables can easily be controlled. Here, now we will see access control. Access control is a security technique that regulates who or what can view or use resources in a computing environment. Now, it is a fundamental concept in security that minimizes risk to the object. Now, in other words, access control is a selective restriction of access to data. Here, public members are accessible from outside the class. Okay, now we will see in this access control, protected members of a class are accessible from within the class. All members in a Python class are public by default, whereas by default in C++ and Java they are private. Right? Here any member can be accessed from outside the class environment in Python, which is not possible in C++ and Java. Okay. Now here